So in this video, we're going to explore classic work equals rate times time problems, and we're going to introduce the problem in the context of Christmas wreaths. So here's the idea. The idea is you have already seen the classic distance equals rate times time formula. And this is really just a specific case of a more general type of equation which says that the work that you get done, if we assume that you work at a constant rate or speed, the work that you can get done equals your rate times the time that you work, or W equals RT. This also means, if you look at this, that if you divide both sides by time, then we see that the rate at which you get things done equals the amount of work you do divided by the time that you have been working. So this is another way to conceptualize this formula, is just manipulate it as a literal equation and solve it for rate. So here's an example. Let's suppose we're going to make Christmas wreaths. And we have an employee who makes Christmas wreaths for us. So employee 1. And let's say that they can get done a certain amount of work. And the work that they do is making wreaths. So this employee can get done 6 wreaths per hour. Or sorry, 6 wreaths. And we'll do the time separately. I have to spell it right. Wreaths. Let's say they get done 6 wreaths, and the amount of time it takes them to do 6 wreaths is 1 hour. From this, we can extrapolate their rate because we know the amount of work they got done, and rate should be the amount of work you get done, in this case 6 wreaths, divided by the time it takes you to get that work done, so 1 hour, which just simplifies to 6, but we know that this 6 has units, it's wreaths per hour. So if we know the work that was done and the time it took to do that work, we can calculate the work rate by taking the ratio of work done to time. So I could do something simple like ask, how long will it take to make 24 wreaths? So to do this, I could say, hey, the work that I get done equals my rate, but now I know my rate is 6 times the time it's going to take me to do it. But if I know how much work I want to get done, I replace work with the work I want done, and then I can solve it for the length of time it takes. So 4 hours is the time it would take for employee 1 to make 24 wreaths. But what we can do is introduce a second employee. We can say, hey, let's introduce employee number 2. And we can say that let's say that the employee number 2 is able to get 5 wreaths done in the same 1 hour that it takes employee 1 to get 6 wreaths done. So employee 2 is just slightly slower than employee 1. Well, we still can calculate employee 2's rate because their rate is the work done, 5 wreaths, per the length of time it takes to complete that work per 1 hour, or just 5 wreaths per hour. So then we can ask a question like this. We could say, how long will it take them to get 24 wreaths done if they work together? So this brings up another big idea in the work equals rate times time problems. So the key idea is that the rate, R, at which 2 objects, 2 people, 2 machines, the rate at which, if we assume constant rates, the rate at which they can get work done together equals the sum of their rates. So if I have the rate of employee 1 represented with R1 and the rate of employee number 2 represented with an R2, then the rate at which they work together is just the sum of their speeds or rates. So in this case, we have 6 rees per hour is what employee 1 can do, plus 5 rees per hour, which is what employee 2 can do. So the rate that they do things together should equal the sum of their rates. They should be able working together, as long as they don't impede each other's progress, they should be able to get done 5 rees per hour. So I can ask, a classic question would be to ask, how long will it take the employees working together to get the job done? And so one way we could do this is say, if I want 24 rees done, then that's going to equal the sum of their rates times time. I don't know how long it's going to take them to do it, but we know that the sum of their rates is 11, so we get 24 equals 11 times time. And you divide both sides by 11 to get time. And that's going to be 2 and 2/11 hours. So that's one way to conceptualize it, is doing this, the sum of their rates. And then set up a work equals rate times time situation. The other way to do this is to recognize that we have work divided by time, which is a rate, and we know that the rate together equals the sum of the rates. There would be another way to kind of go about this. What we could do is say, if I want to know how long it takes them to get 24 rees done, what I could do is I could set up the rate together. I could say the rate together, which has to equal work that gets done. And I know the work that I want done. The work that I want done is 24 rees, divided by the length of time that it's going to take to do it. And what we could do is let time represent the time it takes them working together to get the rees done. And this would give me my rate together, 24 rees per T hours of time. And the rate at which you work together, 24 over T, should equal the sum of the rates. And in this case, we know the rate of employee 1. The rate of employee 1 is 6, plus the rate of employee 2 is 5. We get 24 over T equals 11. Multiply both sides by T. We get 24 equals 11 times time, and then we divide both sides by 11, and we get the same thing that we got doing it the other way. We get 2 and 2/11 hours working together. So we can look at it two different ways. We can tackle these problems using work equals rate times time, or we know that we can calculate rate by taking the ratio of work to time, like I did here, work done to time it takes to do it, and that time can be an unknown. And then we can use the idea that if we assume constant rates, then the rate together is going to be the sum of the rates that the individuals can do it alone.